Temperatures are falling, the snow is flying, and the winds are fierce up and down the entire eastern seaboard. I'll have all the details, plus a look at the upcoming winter storm set to affect the central and eastern portions of the lower 48. So hold on to your hats, folks. A new episode of Cold Rain's Weather World starts right now. Hi folks and welcome to the channel. My name is Jason Pritchard, your host, and you're here for another fun-filled action-packed edition of Cold Rain's Weather World, where we talk about current and upcoming weather events. And we have a lot to talk about today. There are a lot of weather events going on around the country. We've got high winds across the eastern seaboard. We've got winter storm warnings in effect. We've got extreme cold warnings for below zero temperatures with minus 50 to 60 below zero wind chills. And we've got the potential for a central and eastern winter storm that's going to take shape over the work week. So we're going to cover all of those things, and I'll put timestamps down below in the description section so that you can skip ahead to the part that might be most interesting to you. So we'll have that, plus today's trivia question and a word from a new sponsor. So you won't want to miss that. Before we get into any of those things, though, I want to ask you to please consider subscribing to the channel. It's fast, it's easy, it takes one click down below on the subscribe button. You see that on the screen. You also can hit the like button if you like the content. It's the little thumbs up icon. And please consider making a comment. It can be a question about me, it can be a question about the show, it can be a question about a weather phenomenon or a suggestion for the show. But more importantly, we want to encourage each other and lift each other up here on this channel. And one of the ways that we can do that is by praying for each other. And so leave a prayer request if there's something that we can pray over for you for. I'll leave that in the comment section as well, and we'll make sure to do that. I want you to leave the channel every day feeling informed about the weather, of course, but also to feel like you've been encouraged and that we've had a good time and had a little fun and been entertained and maybe even learned a few things along the way. So with that, let's get right on into today's trivia question. This question today is about hurricanes. You can measure hurricanes in a couple of different ways, by wind speed or by pressure. And so today we are going to ask our trivia question as it relates to wind speed. So here it is. What is the name of the strongest hurricane ever recorded by wind speed? Is it A, Andrew, B, Patricia, C, Hyann, or D, Schwarzenegger? Now, if you know the answer, go ahead and type it in the comment section. Don't say it out loud. We don't want everybody else to hear it. But if you don't know it, then we'll get back to this at the end of the show, and I'll reveal the answer. So we're going to start here on our hazards page. This is the National Weather Service Interactive Hazards Map, and you can see there are a lot of hazards. It's been a busy couple of weeks. We've looked at this map every day, and we've seen multiple hazards across the country. And this map shows you where all the watches and warnings are, and we've got watches and warnings galore. Winter storm warnings out here in the upper Rocky Mountains. We've got cold weather alerts all up and down the central part of the country, extreme cold watches, extreme cold warnings, winter storm watches for that storm I was telling you that's going to take shape over the course of the work week. And if we click in here, we can see, actually, we'll go up to into say Bismarck here and see what this looks like. So we've got Bismarck, North Dakota. We've got extreme cold warnings all the way through much of the work week. You can click on this map, find your local forecast office, click on your county, and see what's going on here. So it's -1 currently. We've got -30, -35, -30 for the low. Extremely cold temperatures. It didn't even get above zero all the way until we get to Thursday. So we've got a long period of time below zero, and wind chills are going to be rough, folks. It's going to be -50 to -60 degrees below zero. You'll get frostbite in 5 minutes if you're out there with exposed skin. So stay indoors, bundle up, limit your exposure outside. Across this entire area, it's going to be just very, very cold, unrelenting again. The polar vortex is coming in yet again, and there is hope if you like warmer weather by the end of the 12 to 14 day period. It looks like we might get a little bit of a break for a time. So very cold weather here, high wind warnings and watches up and down much of the eastern seaboard. We're under some sort of a wind advisory or high wind warning. We've had gusts in North Carolina here into the 40s, close to 50 in spots, maybe even over 50. I haven't checked all the obs, but it's been very windy. I'm in Morganton. I'm looking out the window right now. It's just windy all day long. And we've got high wind watches and warnings, winter storm warnings up here for areas that are going to pick up 12 to 14 inches of snow up in Vermont and New Hampshire and Maine and eastern New York. Some of this is going to be mixing with sleet and freezing rain, so you're going to have a little bit of icing concerns, particularly on the southern end of all of this stuff here. So that is our hazards map. Now I'm going to show you the satellite picture, or actually let's look at the current surface map. So you can see what's driving that. We've had the low pressure system that took shape out over the Ohio Valley yesterday and moved on off and is moving on off to the northeast now. This spawned this cold front that brought lots of wind damage across the deep south here. I don't think we had a lot of tornado. We had tornado warnings, but I don't know that we had any actual confirmed tornadoes. But we did have a couple of hail reports, but mostly a lot of wind damage here. Showed you yesterday that strong 850 millibar jet that just cranked on through, and it strengthened, and that's the culprit for today's wind up and down the eastern seaboard. The rain showers are moving off the coast, and we're left with just this cold front with a little clearing behind the front. The next little front's coming through. This is going to usher in cold Arctic air and lay the groundwork for a winter storm that's going to take shape into the middle portion of the week. Tuesday out here, Wednesday and Thursday along the coast. So that is our current surface map. Big high pressure is about to dive in and bring some really, really cold air. Now, if we take a look at our satellite picture, I'll show you a couple things here. Let's put this into motion. So we've got our storm up and down the East Coast. I'm going to zoom in here a little bit and bring this over so you can see it well. And so here we go. So you can see most of the country, but we've got most of the country, at least 75% of it, under some sort of cloud cover. And so we'll put that into motion, and you can see this. Now, this storm is pulling on off over the next day. This is going to get on out of here, and a new system's coming into the West Coast. And so a satellite picture does a good job of kind of showing you this good high-resolution image here. You can start to see some sun. I'm looking out the window here, and there is sun breaking out. So we are going to have a little bit of sun before we get sucked back in with clouds and weather once again. Now, I'm gonna bring this out. Actually, I went the wrong way. I'm gonna bring this out and show you something really interesting here. Check this out. Look at this big gyre out here in the Atlantic, man. This storm system's really cranking up here. It's starting to get night, so we're seeing that boundary come in. But look at this. This takes up the whole entire Atlantic with its cloud field. If we put this into motion, we can see this thing just spinning out here. This came off the coast of northern Canada here and just south of Greenland. And this thing just spinning out here. And see this cloud canopy coming all the way down into Bermuda. I mean, there's clouds associated with this all up and down the Atlantic. This is an interesting image. I just wanted to share that with you. And on the West Coast, we can see another system that's about ready to come on in. This is going to be the catalyst for the development of low pressure here in the center part of the country that tracks on off toward the east. It's going to merge with another piece of energy dropping out of Canada, but this is coming on shore soon. So we'll have a good understanding of how what this really looks like and how this is going to interact with this other piece of energy dropping out of Canada to set the stage for our storm. What you're seeing here, folks, is a map from the Weather Prediction Center. Sometimes we see the hazards map from them. I'm not going to show that today, but I'm going to show you this probability map. This is a probability of 1/4 of an inch of liquid equivalent being snow or sleet. So what does that show us? So if we go here and let's drill in and recenter this map, and you can see areas from Greensboro to just north of Raleigh up to Richmond. The Weather Prediction Center says 1/4 of an inch of precipitation is going to fall, and that's going to be in the form of snow or sleet. The probability of that is 70 to 90%. So that's pretty high in this area. I've been watching the models converge on their essentially where they depict the highest snowfall totals, and it's generally in this area. Off some of the more recent guidance has this on off a little bit to the east. That would include areas north of Norfolk and right in this area here, maybe northeastern North Carolina. So we're going to watch this evolve over the course of the next couple of days, 50 to 70% from DC to Charleston to Greensboro down to Charlotte, and then a little bit less from there. There's just some uncertainty on the track yet, right? We're still 3 days out from how this is going to evolve. We've got two pieces of energy that are going to come together. We call that phasing. That's going to take shape, and we don't know exactly how that's going to unfold. The models have trended a certain way, but oftentimes we see them kind of trend back in another direction as we get right up to game time. And so we're going to be watching all of that stuff. But the best guess right now is that this light blue area here is the best footprint for the snow. So as we dive into this, we're going to look at several maps. We're going to see some snowfall output. We're going to see upper air maps and jet stream maps. And I want to show you a couple of soundings too. We're going to take a look at that. And it's going to be fun. Before your eyes glaze over, don't leave. Stay with me. We're going to have a good time. And I'm going to make this very easy to understand. We talked about soundings yesterday in terms of severe weather. We're going to look at them today in terms of winter weather. They can show you a lot about winter weather and what type of winter precipitation that you might get. And we're going to look at all of that right after these messages. Here at Cold Rain's Weather World, we're a small outfit, but we're spunky. We're an upstart and we're a disruptor. But to keep the lights on, we need funding. And for funding, we need sponsors. And I've got a new sponsor today, Almost There Shipping Company. If you've got any ideas, though, of a sponsor that we could use, please list those in the comments section. And as always, we'll take it under advisement. So as I said, today's sponsor is Almost There Shipping Company. Are you tired of first-rate shipping companies who ship fast, deliver quickly, track packages accurately, and get your items to their destination safe and sound, and all for one low cost? Well, if so, give Almost There Shipping a try. At Almost There, we almost make sure everything gets almost done. So our prices may be higher, but that doesn't stop us from almost meeting almost all of your shipping needs. We almost make sure that your package arrives at its destination. And if you want to track it along the way, you can almost do that by using our easy-to-use app. It only takes 32 clicks to locate your tracking number. And when you do, just sit back, relax, have a cup of coffee, and wait while your tracking information almost comes up. We've had customers tell us they waited hours or even days. Heck, some of them are still waiting. And if your package does eventually arrive, you can rest assured that it will almost be in one piece. Plus, shipping is easy. Just walk up to any of our friendly shipping centers. They're likely to be closed, sure, but hey, you almost made it. So give us a try at Almost Shipping. You'll almost be glad you did. Additional charges may apply when shipping within the United States. Thank you very much for today's sponsorship, Almost There Shipping Company. Okay, we're back with an important announcement. Just a reminder, tonight is not a night to change your clocks back. Okay, now with that, we're going to dive into our upcoming winter storm and what's going to happen with that over the course of the work week. Now, we're going to set the stage by showing you the 850 temperature anomaly map because this is what leads to our winter storm. If we didn't have cold air, of course, it would just be rain and nobody would really care all that much. But everybody's excited because there's potential for snow, and so we're going to see how that breaks down here. So starting right here at 0 hour, this is the European model. Now we're going to be looking at the European model deterministic run. We're not going to look at the ensembles or any of the other models today. Most of the models are kind of converging in the same way, and the European generally scores the best, so we'll just show that today. So we're looking at the 850 millibar temperature anomaly map. This is magnitudes above or below normal. Purples, these deep purples are scale breaker anomalies. These are off the chart, so we're looking at minus 20 or lower in terms of below average, and then you've got warmer than average along the coast. Now watch what happens as we move in time. We looked at those extreme cold warnings earlier, and this is the reason for that. The polar vortex intrusion, and so you can see that anomaly coming in, working through the Dakotas down into Nebraska, into Kansas and Texas, and Nebraska eventually takes the brunt of this. This goes on into Kansas, and then it mutes or moderates over time as you expect it to do as it moves out of the Arctic. So this big cold blast is coming in. High pressure is driving this down. Big, strong 1050 plus millibar high pressure coming in into Montana, into North Dakota, and then spreading out east. And it delivers all this cold air into the east. This sets the foundation up nicely for a nice winter storm, assuming we can get precipitation to fall into that air mass. And it looks like that's going to happen. So that'll just play out over time, and we'll stop it there. Now, the next map that I'm going to show you is I've been showing this last couple of days. This is our upper level energy map. This is called vorticity, these little pockets of energy where these bright colors are. Uh, you may hear the term vorticity from time to time. Just think of that as energy. That's what that means. If anybody ever says vorticity to you, think of it as spin in the atmosphere, which is just energy to create a storm. What's going to happen is this piece of energy here in the southern jet. This was out here over off of the northeast coast out into the eastern Pacific. We saw this on the satellite image before. This is going to traverse the southern part of the country like this, and then boy, I can't draw an arrow. And then this energy coming out of Canada is going to catch up to it and try to phase with it, merge with it. We call that phasing in meteorology. And so those two pieces of energy are going to combine forces somewhere along the coast. Now, a couple of days ago, the European model was showing that happening a little bit earlier, kind of back in this area here. And that led to a much, much larger outbreak of precipitation. And since it's so cold, much of that was snow, and portions of the mid-Atlantic and New England just got pummeled with heavy snow. That's what the European was showing. Now it looks like that phase is going to happen a little bit later. So what that means is that instead of a massive area of snow, we're talking about a smaller area of snow and further east. So your snowfall is going to look something like this with the current runs. Now, no model is going to be 100% accurate 3, 4, 5, 6 days out. We're about 3 days out now from this getting into the East Coast. So we're going to watch these systems kind of come together, and how they come together is going to make all the difference in terms of who sees how much precipitation in the form of snow, sleet, freezing rain, and what type of precipitation that we see. So the trends have been certainly to really slow down the phasing and make it more of a later phase. And if that happens, you're going to see less and less precipitation. You're still going to see precipitation across this area here, but it may be a little bit less if these trends continue. It's possible that they will shift back. We see that happen a lot as we get right into game time. This area is not even on shore yet, so maybe it gets sampled a little bit differently and comes in a little stronger, and you might see a little more robust precipitation reflection. This is the jet stream. The jet stream is important because within the jet stream there are jet streaks like this. And where these jet streaks form, depending on where you are in relation to this jet streak, you could have additional lift or support to create storms. The right entrance region, the left exit region of these jet streaks, this is a little... That's where the darker colors is. That's where the jet streak is. That's where you get lift. And lift is important to create clouds and precipitation. This was a lot stronger the other day. It's weakened a bit too. So we're seeing a little less precipitation reflected in the surface. And you can see that as the storm takes shape, the jet strengthens there along the south and then moves on out. So what does that mean for the actual precipitation map itself? So looking at the timestamps on this, it starts to get its act together in the central part of the country. We're showing 1 hour precipitation rates here. So we're going to move this on along, and you can see as we get into Tuesday morning, it starts to really break out over Oklahoma, Kansas, and into Missouri and Arkansas. And you can see as we slide this forward, that whole entire batch of precipitation, it doesn't look very robust. And one of the reasons for that is we're just showing 1 hour precipitation rates here, just so we can kind of track what's falling and how close to our current time this precipitation is actually falling. If we showed a 12-hour precipitation rate panel, then you just see a big swath of precipitation. You wouldn't really know where the storm is all that well. So this is how this kind of moves along. And as you can see, it sort of really fills in as those two pieces of energy start to come together here. The precipitation starts to fill in. You get this icy mess down here in southeastern North Carolina, a little bit of heavier snow now starting to fall. And now you can see a surface reflection down here. Look at that. So you got this low pressure area that's starting to develop off the coast. It's feeling the support, upper level support coming in out of the north. And then you get a nice little band of snow through here. And if we just push this on forward a little bit more, you can see kind of how that unfolds. We'll get the marker off of there. And what does the storm do? It sort of moves on out, right? I mean, so it's going to go on out to sea and go this way. You're going to get a little bit of snow up along in here. And the snow map kind of reflects that. So if we look at our snow total, our biggest footprint of snow is right in this area here. So from, basically Greensboro back down toward, northeast Wake County up into the Tidewater, Delmarva Peninsula, and way out here in the ocean, and you get southern New Jersey. And so there's some, this goes on out a little bit, and you get a little snow up here in New York as well. But it doesn't look like it's a major deal, except for eastern Virginia, northeast North Carolina, and over here into Delaware and southern New Jersey. All these other areas, back in here, Philly and Roanoke and up into New York City, Boston, you kind of get left out of the picture. I'm rooting for you guys. I'm really hoping it somehow the phasing takes place a little bit sooner. We get a much more, much larger QPF bomb out of this thing and really take it to another level. But right now, most of the models have sort of been trending to a little bit of a later phase and a lighter precipitation event. Now, 13.9 inches here, 12 to 15 inches is not a light deal for you guys. This is a nice little precipitation event. So not too shabby there, but a lot of the other areas kind of get left out. You get, a couple inches back down to Charlotte. We're going to look and see how this has trended here in a minute. So don't just focus on the snow amounts 3 days out. Look where the footprint is and look how it's trending. That's how you tell. Okay. So now look at this. Look at this map here. Okay. So you got in North Carolina at the height of the storm here, about 80 hours out. So this is Wednesday. It's going to come through this area, by the way, Wednesday morning into Wednesday evening into Thursday. It's going to work up in this area. So we're talking Wednesday, Thursday. Now, what you see here is a heavier band of snow, and then you see this little orange area is sleet, and then you've got freezing rain down here. So what dictates this? Well, if all of the layers of the atmosphere, from where the snowflakes form all the way down to where it lands on your nose, if all of that's below freezing, it'll be snow. But what happens oftentimes, particularly in the southeast, is that you get these warm layers of air kind of working in, and you can see those warm layers of air looking at different types of model plots and things like that. And if the warm air is too deep or too thick or too warm, it will melt all those snowflakes. They'll turn to rain. But if the temperature at the surface is very cold or below freezing, it will freeze those snowflakes back into either ice pellets, or it'll freeze on contact and be freezing rain. And so that's what the model is showing here. It's showing a warm layer, but this is a surface map, so you can't see that. So how do I know? How do I detect where the warm layers are in the atmosphere, or even if I'm going to have a warm layer? So that is a great question. I'm so glad you asked me, because what we're going to do here is roll this map forward to about, let's move this on over here to 77, let's call it 78 hours. This is what we call a sounding. We looked at this yesterday, and we were looking over here at this hodograph when it pertains to tornadoes and severe weather. We don't care about hodographs now, but we're going to look over here on this side, which we didn't look at yesterday, and we're going to see a bunch of lines, a skew T chart. These are all skewed off, and the temperatures kind of go up this way. But what you want to focus in on here, folks, is the two things. Temperature profiles on the bottom. Okay, so what we're seeing here is, let me see if I can get to a different display that might show this a little bit better. Yeah, this is a good one. Here, let's look at this. All right, so height, we're starting down here at the lower part of the atmosphere where we all live, right here at the ground, and then height goes up just like this, okay? So higher, boom. So this is way up in the atmosphere, and then here is our zero, the Celsius line. This is freezing. You see that number there, 0? And this goes up this way, okay? So as the height goes up, the temperature decreases generally with height. That's generally what we sort of see. And this is your freezing line in the atmosphere. Don't ask me why it's skewed this way. This is called a skew T plot. We can talk about that another time. But for today's purpose, just know that's your freezing line in the atmosphere as you go up. And this is your temperature scale. Cold this way, warm this way. All right. So that's how this works. Now, what we're looking at here, what we want to see is, do any of these, this is your temperature, by the way. This red line is the temperature of an air parcel that's lifted from the ground up. And so what we want to see is, at some point, as that air is lifted, it'll condense out. We'll start to see precipitation clouds, snowflakes will come down. Does this ever warm up or cross over this yellow line? Okay, that's what we're looking for. If it stays below freezing all the way up, your temperature, that's telling you that the temperature profile where you are all the way up in the atmosphere is below freezing. If it crosses this line and gets into this area over here, this is bad. This is above freezing, and it will melt your snowflakes with great efficiency when these lines start to cross over intrude over into this warm sector. So let's advance this on at Greensboro. So here's what I'm going to do. I'm going to go up here and I'm going to advance this along, okay? If we look here, this is where are we looking at? We're looking at hour 81. So what's going on at hour 81 at the surface? This model is telling us here in Greensboro, we've got snow falling. Look, heavy snow in Greensboro. And what do we think when we look at our sounding? Is it below freezing? Yes, it is, all the way up. So this is great. We'll move these lines off of here. This is great. So we've got a nice snow profile, and we'll advance this along. Does it ever go above freezing in Greensboro? Up in the upper parts of that, or the lower parts of the atmosphere? No, it does not. So completely snow, all snow at Greensboro. What about Raleigh? Ooh, look at this. So, hope you can see that. I'm going to scroll this down a little bit. So this is, what hour is this? This is hour 84. Now, if we go back to our snow map, and we move this over to 84, look what's happening in Raleigh. Got a little sleet working in there. Why is that? Well, what is the model showing us? Model showing us that the temperature as you go up in the atmosphere actually gets above freezing. Remember, this is our freezing line. We're going up in the atmosphere, and I got to grab my pen here. See, go up like this. I'm not drawing a straight line, but you get the point. That's the freezing line. But look what's happening here. This area is coming over that line right in here. You see that? That's called a warm nose. So when you hear the folks on TV talk about a warm nose, that's exactly what that is. And what happens is these snowflakes, they form right in this area. So we're looking at about, 15,000, 18,000 feet up there. The snowflakes are forming, and then they fall down and they hit this warm air. Now, this is not very far above freezing, but it might still be enough to melt those snowflakes. But then you've got a very deep layer from here, where it goes back below freezing, all the way down to the ground. A couple of thousand feet. Those raindrops now that have melted have the chance to refreeze, and then they hit the ground as sleet. So you got a little bit of warm nose in Raleigh. This might even be enough to make it snow, keep it snow if the rates are heavy enough. But this is a problem for some parts of the area, and we don't know exactly where that's going to set up just yet. But it's going to set up somewhere, and so some areas are going to get sleet, and while other areas just a bit to the northwest are going to get snow. Now let's look at one more. This is Jacksonville. Holy moly, folks! Look at this. Big warm nose coming in here. Almost looks like 8 degrees Celsius. So this is not good down in Jacksonville if you want snow. Here's our freezing line here. We're below freezing at the surface. We've got this mega warm nose here melting every single snowflake it can get its hands on. And then right down below that, we're back here at about 1,000 millibars right here. We go back below freezing, and then not enough time for those those raindrops to refreeze. So they're going to freeze on contact because you got a nice surface below freezing here, probably in the upper 20s to around 30. And then, so what is our map showing us here? So I'm going to delete those lines. We're sitting here at 84 hours. We'll go back to our map. 84 hours, wham, look at that, freezing rain all over eastern North Carolina. Now that's what this map is showing, and we don't know if this is right, but I wanted to use this opportunity to kind of illustrate how you can look at a sounding and understand what type of precipitation might be falling. And it's useful too because we looked at RDU, and that little warm nose, even though this model is depicting sleet, the warm nose is very small there, and it's only in that one area. And so there may be heavy enough snow to keep this from turning over to sleet. So a lot of good tools out there for you to use. Now let's go out here. Let's go on ahead and take a look. Pop this back on a different display. And we can see here, this is our sleet total. We saw our snow total before, right? So where were we at? There's our snow total. Areas are cut down back here due to freezing rain and so forth. Back here, it's just not enough precipitation. It's cold enough, but not enough precipitation. So we're going to go back to our sleet. And here's our freezing rain total. So this is showing like, what is this? Over an inch of freezing rain. That's unlikely to happen. So don't worry too much about that. But this is where the freezing rain footprint is, and we can just kind of focus on that for now. And then this is a trend GIF, or GIF, or however you say that. This is just showing the last 5 runs of the European model. It's going to start with that big run I told you about the other day where you had these big snow amounts. And look what's happened. It sort of trended, the phases trended weaker and a little bit later. And so this whole snow footprint, I mean, all of these areas have kind of decreased. The model is thinking, hey, the energy is not quite as strong as it was before. And the phase is going to take shape a little bit later off the coast. And so you still get smoked over here along the immediate coast back into southeast Virginia, North Carolina, up into the Delmarva, New Jersey. But, you know, for me back in the mountains, man, I'm sitting here watching the clouds roll in and got my fire on, my hot chocolate ready to go, and looking up at the sky, waiting for the snow to fall. And it looks like it's getting less likely. Now, again, this is the trend over the last few days. We're going to see additional trending as we go into the system. A lot of the other models have kind of shown this trend, but as that energy comes on shore, it gets sampled, we're going to be able to have a better understanding of how all of this is going to play out. So bottom line is stay tuned. We've got 3 days to go. Drink your Red Bull, eat your Oreos, do whatever you need to do to stay up and watch these models come in late at night. You can track it with us at southernweather.com. We're looking at these things as they roll in. They roll in all through the day. As we get into the 48-hour mark, you're going to start to see useful tools, short-range models like the NAM and the RGEM and maybe even the HRRRRRR as we get on into the 12 hours before the storm. So those are some other tools that'll come online. So we'll be looking at models all day long there. I'll be looking at them here and tweeting about them on Twitter. You can follow me there at Real Cold Rain. And that's going to do it for us today. It's been a action-packed show again. I hope you've had a good time. I hope you learned a couple of things. And so we're going to wrap up with today's trivia question. Remember the question? It was, what is the strongest hurricane ever recorded by wind speed? Was it Andrew, Patricia, Hyann, or Schwarzenegger? And the answer is Patricia. So Patricia was very, very strong, 215 miles per hour. That was back in 2015. So a lot of hurricanes that have come and gone. Many have been strong. Many have persisted for a very long time. Many of them have had pressures that are very, very low, but Patricia holds the record for the strongest by wind speed. And with that, we'll wrap the show up today. Take care, everybody. I hope you have a good Sunday afternoon or evening or whatever time that you're watching this video. But this is Cold Rain reminding you, if you didn't like the weather you saw today, there are plenty of models out there all over the place. You can just go find whatever you want. Just find one that you like better, hug that one, and come back in again tomorrow. We'll come back strong and have another show. So take care, everybody. We'll see you. Bye.